Welcome students to the course of IoT-based surveillance system. In this lecture we will look into the IoT enabling technologies. The important contributing technologies are cloud computing, wireless sensor network, big data. In this diagram the three-tier architecture of IoT is shown. On the top application layer exist the network and data communication layer. And the last layer is the sensing layer. Let's understand what IoT is. IoT, Internet of Things. IoT, things support communication protocols and have a internet address. IoT provides the seamless integration to the cyber world and the physical world. To provide this, the IoT requires supporting technologies, which includes wireless sensor network, big data analytics and cloud computing. The IoT enabling technologies can be categorized in 1. Sensing technologies, 2. Data processing, 3. Communication, 4. Application. Sensing technologies. It includes sensors and sensor networks. A sensor is a device that responds and detects some type of input from both the physical or environmental conditions, such as pressure, heat, light, etc. The output of the sensor is generally an electrical signal that is transmitted to a controller for further processing. Wireless sensor networks, WSNs. A wireless sensor network can be defined as a network of devices that can communicate the information gathered from a monitored field through wireless links. The data is forwarded through multiple nodes, and with a gateway, the data is connected to other networks like wireless Ethernet. The data is forwarded through multiple nodes, and with a gateway, the data is connected to other networks like wireless Ethernet. WSN is a wireless network that consists of base stations and numbers of nodes, wireless sensors. These networks are used to monitor physical or environmental conditions like sound, pressure, temperature and cooperatively pass data through the network to a main location as shown in the figure. Depending on the environment, the types of networks are decided so that those can be deployed underwater, underground, on land, and so on. Different types of WSNs include terrestrial WSNs are capable of communicating base stations efficiently, and consist of hundreds to thousands of wireless sensor nodes deployed either in unstructured, ad hoc, or structured, pre-planned, manner. In an unstructured mode, the sensor nodes are randomly distributed within the target area that is dropped from a fixed plane. The pre-planned or structured mode considers optimal placement, grid placement, and 2D, 3D placement models. Underground. The underground wireless sensor networks are more expensive than the terrestrial WSNs in terms of deployment, maintenance, and equipment cost considerations and careful planning. The WSN's networks consist of a number of sensor nodes that are hidden in the ground to monitor underground conditions. To relay information from the sensor nodes to the base station, additional sync nodes are located above the ground. Underwater. More than 70% of the Earth is occupied with water. These networks consist of a number of sensor nodes and vehicles deployed underwater. Autonomous underwater vehicles are used for gathering data from these sensor nodes. A challenge of underwater communication is a long propagation delay, and bandwidth and sensor failures. Multimedia WSNs. Multimedia wireless sensor networks have been proposed to enable tracking and monitoring of events in the form of multimedia, such as imaging, video, and audio. These networks consist of low-cost sensor nodes equipped with microphones and cameras. These nodes are interconnected with each other over a wireless connection for data compression, data retrieval and correlation. These networks consist of a collection of sensor nodes that can be moved on their own and can be interacted with the physical environment. The mobile nodes have the ability to compute, sense, and communicate. The mobile wireless sensor networks are much more versatile than the static sensor networks. The advantages of MWSN over the static wireless sensor networks include better and improved coverage, better energy efficiency, superior channel capacity, and so on. The National Institute of Standards and Technology defines cloud computing as: cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services, that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of 5 essential characteristics, 3 service models, and 4 deployment models. Essential characteristics. Software as a service, SaaS. The capability provided to the consumer is to use the provider's applications running on a cloud infrastructure too. The applications are accessible from various client devices through either a thin client interface, such as a web browser, for example, web-based email, or a program interface. The consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating systems, storage, or even individual application capabilities, with the possible exception of limited user-specific application configuration settings. Platform as a service, PaaS. The capability provided to the consumer is to deploy onto the cloud infrastructure consumer-created or acquired applications created using programming languages, libraries, services, and tools supported by the provider. 3. The consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating systems, or storage, but has control over the deployed applications and possibly configuration settings for the application hosting environment. Infrastructure as a service, IaaS. The capability provided to the consumer is to provision processing, storage, networks, and other fundamental computing resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The consumer does not manage or control the underlying cloud infrastructure but has control over operating systems, storage, and deployed applications, and possibly limited control of select networking components, for example, host firewalls. Cloud computing provides the platform for the data collected from the sensor nodes. The data collected from the WSN are transmitted using the cluster node to the data center. Removes the burden at the edge of the network and provides a better environment for processing huge data. The emergence of Internet of Things, IoT, cloud computing technology, digitization of processes and transactions has led to enormous growth of multifaceted data in every business domain. Big data technology complements the consolidation of islands of complex data, extract new insights or creates new forms of value and adds significant value to the decision-making process among competitive business organizations. This chapter emphasis on big data fundamentals, need of big data, technological advancements towards big data storage and limitations, tools and techniques used to process big data. Further, this chapter also focuses on basics to advanced concepts of big data analytics, few research issues and future directions. Big data is a term for massive data sets having large, more varied and complex structure with the difficulties of storing, analyzing and visualizing for further processes or results. Let's understand the 3 V of big data. Volume. Size matters. The first attribute that makes big data big is the size of the data. There can't be a fixed measure what a big data size should be, but currently it should be in TB or above, but soon it will become more than a petabyte. This definition of size may vary with time and storage and computation availability. Other parameter that quantifies the size of big data can be number of records, or number of files, or the collection size. Volume matters since it requires the more computation to process larger data. Velocity. Velocity describes the rate of data production that constitutes the growth of big data. The growth of smart technologies, social networking and IoT rate production is increasing at very rapid pace. From healthcare to smart home, cloud computing to social networking, from government offices, educational institutes to household, the penetration of Internet and IoT is reached very far. And it's not holding back till saturation. The data is not only generating very fast, but also these data need to be processed real-time. The velocity is causing the real-time storage, availability and processing a challenging task. Variety. The big data includes everything stored on organization server, public cloud data or the archives, so, the variety is present in the big data. The data produced from diverse sources and stored in different servers. The data can be unstructured, semi-structured or unstructured. Data format can vary from textual to multimedia data. The textual data is present in the form of documents, emails, text messages, whereas multimedia data is present in audio, video and images. Apart from that, sensors, devices and machine logs, medical data are also constituent that extend the variety present in big data.